Welcome everybody to our latest webinar edition, Preparing for a Winter Like No Other. 2020 has been an interesting one. When the chimes of the new year and the decade rung through, our main thoughts were probably of Brexit and those associated preparations. And as we fast forward 10 months, who could have predicted the impacts and the challenges we have faced due to the global pandemic? Businesses and economies have been in stasis. Furlough has been a word Googled more times than coronavirus, and Brexit still remains an unknown to us. With all this going on, we still have to consider the day-to-day operational and environmental risks that need acting on. So as we approach the winter months and the challenges that are associated with these months, I'll hand over to Brian Cherry to take you through some of the risks.
Hi everybody. Yeah, we've obviously in previous webinars you may have been involved with, we've covered environmental risk in some detail, but I just thought it'd be useful just to give a bit of context, because ultimately a lot of the mitigation we have on site and the systems we have in place are designed to mitigate an environmental risk. So an environmental risk is an actual or potential threat to adverse impacts to the environment, such as surface waters, the sea, lakes, etc., and to living organisms, which includes ourselves as humans, and to plants and animals that may be living in close proximity to the site. And those impacts can be anything from emissions or wastes or effluents coming from the site, or in the event of an incident, a spillage. So it's anything that any of those impacts, any of those discharges to the environment arising from the activities of an organisation. And obviously if those risks aren't managed correctly, then it can trigger a range of consequences. These get involved a number of stakeholders, regulators, lawyers, third parties. This can result in legal action if the incident is significant enough, and can be costly both from a clean-up perspective and the resolving the impact, and then finally the fines that may follow in the event of legal action being taken. And we've had, I think as Mark touched on, this has been a substantial challenge, and given those challenges we're currently facing, I think it's more important than ever that we try to manage those risks and avoid anything from occurring. And so from a bit more on the risk assessment, the risk assessment itself is a fairly process is well understood. It's the same as what a health and safety one would be. You need, for a risk to be present, you need a hazard. That is something that has the potential to harm you or the environment. That could be storing of hazardous materials, for instance. A risk is the likelihood of that hazard causing harm. So you need both, for a risk to be present, you need the hazard, you need a method of which that hazard could cause impact, and then it needs something that can be harmed. And for environmental risk, we have quite a clear process that's followed, which the process you may have, we've touched on before, is the source pathway receptor principle. This is where you have for there to be a risk environmentally, there needs to be a source of pollution or contamination. So that is effectively the hazard. That may be as I say, storing of hazardous materials, or a spillage incident. There has to be a receptor, i.e. which is something that can be harmed by that hazard. That again, we're talking groundwater, surface waters, plants and animals, human health. And then there has to be a pathway between the two. So a link that allows whatever the hazard is, it allows that to cause harm. So that can be anything from movement through the ground or overground, through site drainage, or just the breathing in of vapours which are hazardous to health. All three of those things combined create a linkage, a pollutant linkage, and that is where the risk lies. In some cases, the source of contamination is on site, in some cases it's off site. So the image in the bottom right hand corner is an example of that, where the site itself can become the source, should I say, is off site. So in this case, a water from a flood event. And I think what's important is that the site can be a source, it can be a pathway and a receptor. And I think sometimes that's often people think it's always something, the receptor is always something that's off-site. That's not necessarily the case. So the site as a source is the storage and use of hazardous materials. It's if there's any construction work being undertaken that may involve the dewatering of excavations and discharging sediment-laden water. It could be any processed water or effluent that you discharge either from a operation of a factory or from sewage discharges from the sewage works or private treatment facilities. The site as a pathway is just the things that's installed on a site that allows the movement usually of liquids. So that's such as site drainage. It's the putting in hard standing surfaces which are impermeable that allows water liquids to run off over the surface. And then as a receptor, you've got your site staff yourself, and the staff are obviously a receptor, and any visitors or users of that site. You've got any plants or animals that may be on site. You'll be surprised how many habitats there are on many industrial sites. And then also it's the impact of business interruption as well, which is a quite a big one, which is both it can be considered as if there was a spillage incident, the interruption from that, but also, as we touched on previously, from a flood incident. And it's important that we understand this principle, understand what the risks are, so we can effectively manage that risk, and without it we won't be able to. So a bit more on environmental risk, and tying that into kind of the winter and the subject of the matter of the presentation is environmental risks are present regardless of the season that we're in. And so as long as a pollutant linkage exists, which we touched on before, then that environmental risk is there. Now, in the current winter, there's some unique challenges that winter brings, but I say, as Mark touched on before, there's a number of other challenges in this moment in time which exacerbates that. So we've had staff that have been furloughed, we've had sites that have been closed, some that have recently reopened, there's staff illnesses, we're currently in a technical recession, some companies have had a vast increase in workload, there's been business restructuring, and then obviously there's Brexit looming on the horizon and what that may lead to from both a business and a regulation perspective. And they are making this current winter more challenging, because a number of the things that have been where sites have been closed, etc., as they come back online, the issues may only be picked up at that time. And similarly, if staff have been furloughed, then the routine maintenance inspection of those sites has often gone by the wayside. And then winter, and then you bring in the fact that winter itself brings unique challenges. They can introduce hazards that aren't there during the summer. They can change the environmental conditions on site and nearby. They can influence the behaviour of a pollutant if an incident occurs, and it can introduce new pathways such as overland flow during heavy rain. And I think with that in mind, with all those challenges and with winter coming, it's important that you understand your risks and what you have to do to avoid any more unnecessary challenges that, let's be honest, you've already got, and I'm sure no one wants any more. So winter itself can have many impacts that some are obvious and some less so. So the site we obviously know about as more rainfall events during winter, so flooding becomes more of an issue. You have storm and wind damage, there's the effect of freezing temperatures and lightning strikes, and these are kind of extreme weather events that we're more likely to get during this period that's coming. So a lot of these are hazards in themselves to the site, which may cause impact, but they can have a knock-on effect and exacerbate issues hazards that you already have on site. These can be the things that cause that hazard or allow that hazard to cause harm to a receptor. And I say in the case of flooding, the site would be a receptor and the water that's from that flood event would be the source. So this is kind of linking back to the site being the source, pathway and receptor. Similarly, things like if sites are being closed, this is as the temperature drops, the heating systems might be the first used for the first time in a while, and as that happens, this might be the first time you realise there may be an issue with the infrastructure around the tank, the fuel lines in it, and boiler, and any of the infrastructure associated with that. And then there's the less obvious things which to bear in mind. So there's things like ground heave, which is basically the expansion and contraction of soil as it gets wet and it dries, and that's all dependent on certain ground conditions, and I won't go into too much detail with that, but that can cause structural issues with buildings, and in the case of, from an environmental risk perspective, bunds and hard standing surfaces. You have thermal expansion and contraction, which is a particular issue in concrete or brick bunds, where water gets in the cracks and it freezes, and as during the freezing and thawing process, that expands and contracts, and causes the cracks to widen, and then that may cause an impact if there's a loss into that bund. You have increased flow rates in drainage and separators, and one important thing to note with this is that a lot of sites might have a bypass separator installed, which is only designed to manage a certain flow rate of water, and that as that goes through the system, if that flow rate is exceeded during heavy rain, then it basically bypasses the whole separating process, and then anything downstream of that will become impacted by any contaminants that's running through the drainage system at that point in time. And then we also have staff behavioural changes, which are, it's human nature during winter. Staff often cut short inspections of key maintenance, and and there's certain bits that they don't want to do, or they make it quicker, and those elements exacerbate any potential risks that are there. And I think it's important to know what the challenges of winter are and how these can increase the risk notably, but it's also important to know that there are options and actions you can take to mitigate that risk, and kind of Mark will cover these going forward.
Thank you, Brian. I'm going to cover off some of the practical things we can do to try and help reduce some of those risks that Brian has spoken about. I'll specifically focus on PPM tasks and things to consider during those tasks. PPMs, we should all be aware, planned preventive maintenance or pre-planned maintenance, many different acronyms. We'll call it a PPM for the purpose of the webinar. And these should be tailored for the individual asset, the site, and the usage. We do them for a number of reasons. We do them to improve on the safety, to try and reduce the risk of a breakdown occurring, to extend the working life of the asset. We do them to follow guidelines, which can be quite complicated, and we do them to provide evidence of compliance, to supplement ISO 9001, 14001, etc., etc. Or we do them because the manufacturer recommends that we do them. I won't cover off every asset. I'll just focus on some of the common issues that we've come across during our experience and time within the environmental industry. Drainage is often forgotten about because it's out of sight and out of mind. Every site should have a plan and understand where the drains go, but they should also be inspected. This confirms that they're clean, clear, they're not damaged, and they're not reducing the flow rate off of site water runoff. Covers and eco channels, they should be clean and clear of silt, leaves, litter, etc. Because drainage is designed to deal with most rain events, and sometimes the car park that keeps flooding is normally down to poorly managed drains. Specialists should help deal with any post assessments if a clean-up of a pollution assessment occurs due to drainage failure. Similar to drains, separators, they're out of sight and out of mind, but they are essential in managing water runoff and retaining contaminants. Things that should be considered: The Environment Agency recommends servicing at least twice a year. Servicing should cover the filters, checking those for cleaning, whether they're saturated or they need replacing. The liquid levels within the separator need to be maintained correctly. Silt should be removed as that reduces the capacity and the retention of the separator. And it's good practice to monitor levels automatically. Finally, I often get asked about integrity checks on separators, and they should be part of a long-term maintenance plan. If you don't know if you have had one, then now is probably the time to consider having one. Rainwater harvesting. As I said before, managing rainwater and recycling water is critical, not only to reducing the flood risk on the site, but also the environmental impacts. For most of us, they're new things to consider, although they have been around for many, many years. Simple things to do are to check the filter baskets are clear of leaves, etc. Sample the water for any contaminants. It might be that the rainwater that's being stored needs to be chlorinated. And ensure that the shut-off valve has been engaged before winter sets in. Tanks during the colder months can bring in increased demand as productivity, heating systems come back online to the storage and the infrastructure. I always say that your starting point should be a risk assessment and then an appropriate inspection. As I mentioned before, guidelines are varied. There are so many of them: Offtech, BS 5410, AMUA, API, Blue Book, HSE, etc., etc. Your specialist partner should know what is relevant for your tank storage and the liquid being stored. Consider checking the fuel for water in fuel systems. Water in fuel can damage systems very, very quickly. You should think about protecting against corrosion. A coating should be specified to protect against corrosion and not thought of as just making the tank look nice. A good quality coating can, for example, prolong the tank and pipework infrastructure by up to 10 years. You should also consider your fueling activities. They should be in well-lit areas as the winter months and the daytime hours get reduced. I come across so many incidents of unlit areas where people have had injuries, slipped over on spills, leakages, etc., etc. So do ensure that they are in a well-lit area. Bunds. They form a key part of the defence against pollution. The integrity and auditing should be done by a professional. Some of the things to consider during your normal PPM tasks: what does the general condition of the bund look like? What happens after rainfall? Again, I often go out and talk to customers and they say there's nothing wrong with my bund. I've got no water in it after 3 days worth of rain. It's probably a sign that the bund is leaking. Any vegetation growth should be removed and the areas be repaired. Check that the sumps are clean, clear, haven't got vegetation in, are working properly. Also checking during those colder months that the sump hasn't frozen over, because this will stop the pumping system working correctly. Check that the capacity is correct for the bund. Again, bunds are often used as storage areas for spill kits, etc., etc. All of these things reduce the capacity of a bund, and it is there to protect you against any catastrophic failures. Finally, the cleanup from a bund during a catastrophic failure can be substantial, not only in cost but in disruption to your business. So in summary, get to truly understand your site. And when we talk about understanding your site, not only just the infrastructure on the site, but the overall environmental part of your site. Brian's mentioned previously regarding the source pathway and receptor. Your site could be any one of these. Know what the consequences and the impacts could be. Know how to respond in the event and what that impact could be. Have an established environmental management system that supports you being able to respond to an incident. Train your staff regularly. Have an incident response plan and also activate that plan as part of your training regime. Get dedicated support. Don't be afraid to pick up the phone, either to us or other providers, to support you during an incident. And have a dedicated PPM plan in place that supports your site. We'll answer as many questions as we can, and we've had the first one through, which is environmental risk inspections and tank inspections have been mentioned a few times. Can you explain what the difference is? I think, Brian, you'll be best for that one.
Thanks, Mark. It's a good question. Basically, in short, a tank inspection or any inspection of any asset specific is specific to that asset. It's to look at the condition of that, making sure it complies with regulations, etc., and its overall condition. The environmental inspection or audit is a much broader picture we look at. It's putting the site into context, in understanding, okay, rather than just you have a tank that contains a hazardous material, it's then looking how can, if that failed, if the primary containment failed, how could that go and what could be impacted and how could that be impacted. So it's kind of the source pathway receptor principle we discussed at the start. So it's a much broader picture. It assesses the site in detail by risk, and it makes you it looks at more than just, so rather than just concentrating on one thing like a tank, it will look at everything to see what is necessary to mitigate that risk. So that, in short, is the difference. And obviously, if you need any more information about any of the tank testing specifics, then we'll one of our colleagues will be able to help you with that. I've also picked up a question, which is, it's a good one, to be fair. How realistic is it that the maximum flow rate for a bypass separator is exceeded, as we discussed earlier, and at the same time as a spillage? And also, how would you know if your site has got a bypass separator? So it's a very good question, and you'd think, I can understand why you think that it's a set of circumstances that you might not think would occur, but we have had experience on a site, or on a couple of sites, but one particularly where there was a period of heavy flow rate through the drainage system at the time, and it just happened to be that there was a loss at that moment in time, and the bypass, the flow rate did exceed that, and product, some was contained within the separator, but a lot of it bypassed the whole separation process and went out into a watercourse adjacent, and that caused quite a substantial impact to both the watercourse and some ecological life. Is quite an important habitat. So, it can happen, and inevitably it always happens at things like this often happen at the time you least want it to happen, and in that case that definitely happens. So you may think it's unrealistic, but I can assure you we have had experience of that. And then from what can you do to check if your separator has a bypass system? And I think Mark will be your best person to answer that one. Yeah,
the real simple answer is have it inspected by an engineer. An engineer can confirm whether you've got a bypass separator. They'll be able to take the measurements of the separator and go away and work out what the flow rates should be, and that those flow rates are compliant with your site. So yeah, an engineer visit. They'll also check other things on the separator. Is the automatic closing device working correctly? Is the alarm system working correctly? Etc. But they'll also confirm the type of model of your separator, more importantly.